Okay, so let's look just at number one here, just to kind of refresh our memory as to what do we need to do, okay, when we're given the reaction in formula form. Well, if you're given it in formula form, you're probably going to be asked to do three things. Identify the type, okay, which is basically, at the start at least, comparing to the examples that you have in your notes. All right, once you kind of get the hang of it, then you don't really need to refer back to your notes, you just sort of remember. Okay, the next thing you're probably going to be asked to do is balance the reaction. And the third thing you'll probably be asked to do is write it out in words. Okay, now on the quiz that we didn't get to write yesterday, that was the 3 marks for each question. 1 mark for balancing, 1 mark for the reaction type, and 1 mark for having everything in the reaction named correctly. Okay, for most people, the trickiest part, okay, at least in this type of question, was the balancing. Okay, the writing out in words, people seem to be able to do just fine. When we moved down to this, however, and I gave the reaction in words, suddenly everything broke down. Okay, and here's why. People suddenly forgot what to do when writing the formula for a chemical compound. Forgot to swap and drop their ionic compounds. Okay, that was the biggest one. Forgot about brackets around polyatomic ions. And then as a result, their compounds weren't right. And if your compounds aren't right, you can't balance the equation correctly either. And a lot of people were getting 1 out of 3, even though they probably knew how to do all 3 things. They just, kind of had a brain fart on how to get the formulas done. Just forgot the little naming rules that I told you right at the beginning are so important. Okay, so that's why we want to go over these kind of examples. Somewhere you're asked to write it out in words, and somewhere you're given it in words. Because most likely on your unit exam, the questions you'll get will be more like 6 through 10 here, which is I'm going to give you the word equation. You're going to have to write out the actual chemical equation, balance and identify. Okay, or I give you just the reactants in word form. You predict and balance, okay, which we'll get to next week. So we want to go over that kind of stuff, get practiced up, and remember kind of some rules to do with that. Okay, so we're going to do number 1 together here, and then I'm going to have you do 2, 3, 4, and 5, and then we'll go over those. Okay, so for number 1 here, first thing I want to do is I want to identify the type of reaction that's going on. Okay, looking at this here, I've got a single compound as my reactant. Okay, and there's only one kind of reaction where there's only one reactant. What is it? Decomposition. It's not reacting with anything. It can only break down. All right, so it's a decomposition reaction. So that would be the first thing we would write down, is that this would be a decomp reaction. Okay, next thing we would probably do is write it out in words. Right? This is a molecular compound because it contains 2 nonmetals, so we're going to need some prefixes for this. Okay, so we're looking at trinitrogen dioxide. All right, and that's going to break down into nitrogen and oxygen. Why are nitrogen and oxygen both 2s on that side? Because they're highlighted on your periodic table. They are what we call the molecular elements. That is, when they are in their element form, that is, by themselves, they come as a pair. All right? So there's a bunch that come as a pair, phosphorus that comes as a 4, and sulfur that comes as an 8. Those are ones we have to keep in mind. Okay? A lot of people yesterday when they wrote the quiz weren't looking at their periodic table. Okay, they remembered, oh yeah, sulfur's an S or oxygen's an O, and they just wrote it down without checking to see if it was one of the special elements that's highlighted on their table. Okay, all right. So now I've got it written out in words. Now I need to balance. Okay, we try and do oxygen last, we've always said, and we usually pick the thing that's present in the highest number first. Okay, nitrogen's present in the highest number. Okay. There's a 3 on this side and a 2 on this side. That's kind of that odd even issue we talked about before. So how do I solve that problem? Put a 2 in front, right? Okay, so I double the odd side, and that'll give me an even number of nitrogens. 2 times 3 is 6. So 3 times 2 is 6. Now my nitrogens are balanced. 2 times 2 is 4 for the oxygens. So 2 times 2 is 4 for the oxygens. Okay. Now, one little thing, just in case it ever happens. It doesn't happen very often, but just in case it does happen. If you happen to have all numbers across that you could reduce, do so. For example, sometimes people make this too big. Okay, and they make the balancing numbers 4, 6, 4. Right? It's balanced. Okay, there's equal numbers of everything on both sides, but you could reduce all of those numbers by dividing by 2. Okay, so if that ever happens, make sure you reduce it down to the lowest form. It doesn't happen very often. Okay, I want you guys to try 2 through 5. Okay, I'll give you a few minutes to do those, and then we'll go over them together. Okay, so we're looking for reaction type, written out in words, and correctly balanced. Oh, don't worry about it. Just write fuel. Yeah, yeah. Guys, for number 3, when you're writing that out in words, okay, I don't know what the prefix for 14 is. I don't remember it either. You can either call this fuel or you can call it hexane. That's actually what it is. Okay, but you haven't taken organic chemistry where you learn how to name organic molecules yet. That's Chem 20. Okay. I would never give you one like that on a test. Okay, just so you know, anytime I give you one on a test, the prefix will be less than 10. How many people have done 2 and 3? Okay, let's just stop what you're doing. Let's go over 2 and 3 here. Wow, I've been recording that the whole time. All right. Okay, no worries. I didn't say anything that would get me in trouble, so that's good. I didn't go to the bathroom with the mic on. That one's the worst. Okay, so for number 2 here, we've got an element. You're still chuckling about that because it is funny. Okay, calcium is reacting with an ionic compound. Okay, and that is iron chloride. Okay, iron 3 chloride in this case, and it's producing an element with another ionic compound. So, what kind of reaction starts out with an element reacting with an ionic compound? Jacob? Single replacement reaction. Okay, now in a single replacement reaction, we have to decide who's getting replaced in this compound. Something has to go, okay, because calcium's got to move in there. So who's going? Iron's going. Okay, we replace the thing that is like what the element is. All right, so calcium is going to replace iron here. Okay, and we're going to end up with that over there. Now, when we do that, okay. Sorry, we said this is single replacement. Okay, now we've got to write out the names. Obviously, since calcium is by itself, we don't change its name at all. Okay, calcium plus, and then this is iron chloride. How do I decide which iron? Okay, we look at the non-metal, right? And the non-metal has a charge of -1, and there are 3 of them, which means there's a total of 3 negative charges. So if I only have 1 iron, its charge must be +3. Okay, and that was something else that gave people trouble in the quiz yesterday. They just forgot, okay, how to do Roman numerals. All right, so we got calcium plus iron 3 chloride, okay, gives us iron plus calcium chloride. Now, do I need to put a Roman numeral on iron when it's an element? No, because it doesn't have a charge when it's an element. The number of protons and electrons are equal, so it doesn't have a charge. Okay, so we don't use a Roman numeral if it's by itself. Okay, now we've got a balance. So the only thing right now that's out of balance is chlorine. And there's 3 of them on this side and 2 of them over there. Lowest common multiple is 6, or I double the odd side. Okay, and I go over here and I put a 3 there. Now, I got to put a 2 here with iron, because I made a 2 there with iron. Okay, I've got 3 calcium over here, so how many do I need here? 3. All right, and we're balanced. Okay, everybody all right with that one? All right, next one. We've got a hydrocarbon, in this case hexane. So it contains carbon and hydrogen reacting with oxygen gas to produce carbon dioxide and water. What kind of reaction is that? It's a combustion reaction. Okay. All right, so it's a combustion reaction. Now we got to write it out in words. Hexane plus oxygen, okay, gives us carbon dioxide and water. Okay, now, rules for balancing combustion reactions. Balance alphabetically and the rule of 2. Do they both apply in this one? Yes, they do. Okay, we have an even number of carbons, so we have to apply the rule of 2. Okay, that gives me 12 carbons, so I got to put a 12 here. It gives me 28 hydrogens. Yeah? Now I've got 28 hydrogens over there, 14 times 2. Now I've got to balance the oxygens. There's 14 oxygens here, and there's 24 here, which gives me a total of 38. Okay? 19 times 2 is 38. Everybody all right with that? Yes? Okay, we've done that reaction a few times now. Okay. All right, I'll give you a few more minutes to try 4 and 5, and this time I'll remember to pause the recording. All right, so for number 4, I've got 2 elements reacting to form a single compound. What kind of reaction is that? Synthesis, right. Okay, so we got a synthesis reaction here. Okay, written out in words, we've got chlorine plus lithium, okay, gives us lithium chloride. Okay, only thing that's out of balance is chlorine, agreed? Okay, so putting a 2 here will balance chlorine, but gives me 2 lithium, so a 2 there is required. All right, for number 5, 2 ionic compounds are reacting to make 2 different ionic compounds, which is a double replacement reaction. Okay. All right, rather than write it all out in my terrible handwriting, this stuff here is magnesium fluoride. This stuff is cobalt 3 nitrate. Okay, here's how we know that. Nitrate is a -1. Okay, and there are 3 of them. Since there's only 1 cobalt, it has to be a +3. Okay, so we'd be looking at cobalt, Roman numeral 3, nitrate. Now, here's the good news about double replacement reactions that have Roman numerals in them. Whatever the Roman numeral is on the reactant side, it's the same on the product side. You can't change the material you had in the middle of a reaction. So if you figured it out on one side, it's the same on the other. Don't figure it out again. Okay, so we'll end up with magnesium nitrate and cobalt 3 fluoride. Okay. Now we got to balance. What should I balance first? Jacob? Nitrate. Yeah, and I could balance fluorine as well. It doesn't really matter. They're present in the same number, but we'll start with nitrate. Okay. So I've got 3 nitrates over here, and I've got 2 over there. So we got the odd even thing going on. So we'll put a 2 here to get rid of the odd number. That gives me 6 nitrates. All right. So over here, I'm going to have 6 nitrates. Now, when I put this 2 here, it also gave me 2 cobalt, so I got to go over here and put a 2 there. Okay. When I do that, it gives me how many fluorine? 6. So I got to go over here and make 6 fluorine, and that just happens to also work out with my magnesium being 3 on both sides. Okay. Everybody with me there? Okay. So those 5 tend to be the easier type of reaction questions you're going to encounter. The harder ones are like 6 to 10 here, where I write it out in words, and now you've got to assemble the formulas. If you don't assemble the formulas right, you won't get the balancing numbers right. That's what makes it more difficult. Okay, is if you make one mistake, you are automatically not going to get the next mark. Okay, you may be able to balance the reaction you wrote, but it's not the right reaction. You follow me? If you don't get those compounds right. So remember your swaps and drops. Okay, that's the biggest thing. The other thing you got to watch for, if any special elements are made in the process of the reaction. So that is like if you get any of the ones that are highlighted on your periodic table as a product or a reactant, you got to remember to put their little number beside them. All right, so I'll give you a few minutes here. Okay, try 6 through 10 here. Okay, and then we'll go through them 2 at a time or 3 at a time like we did there before. Okay, actually, you know what? Let's do number 6 together just so you see it done. Okay, for number 6, we got copper 2 nitrates. Okay, so copper with the 2+, that's what the Roman numeral tells me. Okay, nitrates. All right, I put it in brackets because I know when I drop and swap, I'm going to need a 2 here. Nitrate's a -1, so okay, that compound is good. Okay, reacts with magnesium. Just magnesium by itself. Right? And that's going to produce magnesium nitrate and copper. Now, what do I need to do with this compound? Because I haven't done it yet. Shay? I got to swap and drop. This is a 2+. Okay, this is a -1, so when we drop and swap, we're going to get MgNO3 2. All right. Balancing-wise, this one's easy. Why is this one easy to balance? No, it's not a combustion reaction. Oh, no. Okay. Why is this one easy to balance? It's already balanced. Okay. There's 1 copper, 2 nitrate, 2 nitrate. Okay, 1 magnesium, 1 magnesium. So it was already balanced. So we just go 1. Okay, so we just go 1 on everything. Okay, and then what kind of reaction is it if I have an ionic compound reacting with an element? Single replacement. Okay, so that's what you're going to be expected to do for the next 4. Okay, write it out in formula form, balance it, and give me the reaction type. Okay, I'll give you a few minutes to try those. Okay, let's have a look at number 7 here. So we've got C12H26 reacting with oxygen gas. All right, and that's going to produce carbon dioxide and water. Okay, what kind of reaction is that? Combustion. Okay. So in a combustion reaction, we have to remember our special balancing rules, both of which apply to this reaction because 12 is an even number. So we are going to have some gigantic numbers for balancing in this reaction, and that's what happens when you burn big molecules. Okay, so we've got 24 carbons needed here, okay, and we have 52 hydrogens needed here, so that's 26 times 2. Okay. Then we got to balance our oxygens. So 24 times 2 is 48. So we got 48 there, and we've got another 26 there, right? So we got 74 oxygens. Okay, is that right? Hopefully my math is okay. Okay, 74 over 2 should be 37, yeah? Okay, so I need 37 oxygens there. Okay. I wouldn't give you one that had big numbers like that on a test. I'd give you a much smaller one. Okay, questions on that one? Okay, walking around and looking at what people did for number 8 is the whole reason we're doing this morning. Okay, what did I say you needed to remember to do? Drop and swap. I walked around and saw a lot of people who didn't do that. Okay, lithium nitride, Lin -3 plus 1. So we're looking at Li3N. Yep. Carbon dioxide. Yeah. No, 2 times 12. Right? Yeah, that's okay. All right, so lithium nitride breaks down into nitrogen and lithium. Okay, walking around, I saw a lot of people forgot to swap and drop lithium nitride, or forgot that nitrogen was a pair. Okay, so those are the little things. If you don't have those numbers there, you're not going to get the balancing numbers right either. Okay, so now, what kind of reaction is that? Decomposition, yeah. Breaks down always means decomp. Plus, there's only one reactant. All right, now we got a balance. I've got 3 lithium over here, but if all I do is go over here and put a 3 in front of lithium, I'm going to be erasing that and changing it right away because I've got 2 nitrogens on this side and only 1 over here. So I'm going to fix my odd-even problem with the nitrogens. There's an odd number of them over here. So I'm going to put a 2 there. That gives me 6 lithium. So we're looking at 2, 1, 6 for our balancing numbers. Okay, questions on number 8. Okay, how many people are done 9 and 10? Okay, I'll give you like 2 more minutes and then we'll go through those so we don't run out of time. Okay, let's quickly have a look at these here before the bell goes, guys. Hydrogen sulfide. Okay, hydrogen sulfide is an ionic compound with hydrogen and sulfur in it. Okay, this is a -2, this is a +1, so we're looking at H2S. Okay, reacts with calcium hydroxide, Ca with OH. This is a 2+, that's a 1-. So when we swap and drop, we need brackets with a 2. Okay, and that produces calcium sulfide. Both of those are 2s, so they cancel each other out. Okay, and hydrogen hydroxide, otherwise known as water. But I am going to write water, in this case, like hydrogen hydroxide, just because it'll make it easier to find out where everything came from. Okay, so on this side, I'm going to start with hydrogen. On this side, there's 2 hydrogen. How many are there over here? Well, yeah, a lot of times we think 2, but here's the thing. This hydrogen is from hydroxide. I've already accounted for that with this. So I only have 1 hydrogen here, all right? So I need to put a 2 there. And when I do that, that balances my hydroxides, doesn't it? Okay, makes it kind of easier that way to figure out where everything came from. All right, and then everything else is already balanced. Okay, what kind of reaction is that? Double replacement was 2 ionic compounds. Okay, and our last one here, okay, phosphorus, P, special or not? Special, P4, reacts with oxygen, O2, to produce triphosphorus dioxide. Okay, have I got the odd-even problem here? Yes, okay. But if I double this side, does that help me? Not really. What's the lowest common multiple of 4 and 3? 12. That's what I've got to do. A 3 here and a 4 there. Okay, 4 times 2 oxygens gives me 8. Wow, perfect timing. Have a good weekend, but not too good.